Hello. For our project, I chose to do a video, and I have 3 different graphs, and I'm going to explain how they are either consistent, inconsistent, dependent, or independent for each separate example. For my first system of equation, I have y plus 4x equals 12, 3y equals 8 minus 12x. Now, to solve for this equation, to determine whether it's consistent, inconsistent, dependent, or independent, I need to put each one of these into slope-intercept form. So I'm going to take the first one, y plus 4x equals 12. I'm going to subtract. I'm going to subtract the 4x to the other side so I can get the y completely by itself. Now what I'm left with is y is equal to negative 4x plus 12. Now as I draw this on the graph, I have to first label my y-intercept. Now since, 12 is out here by itself with no variable attached to it, it is going to be my y-intercept. So I'm going to start by labeling 12, and then since my slope is negative 4x, my rise over run will be either negative 4 over positive 1 or 4 over negative 1. So to start off, I'm going to go down 4 and then to the right 1. After I've created enough coordinate points, I'm just going to create a line, connecting all of them. Mind you, that may not be the most straight line I've ever drawn, but it's a rough estimate. Now I'll repeat that same process for the second one. 3y equals 8 minus 12x. Now to start off, I'm not going to show this step, but you're going to divide 3 on both sides to get the y completely by itself. And what you're left with is y is equal to negative 4x, which you get negative 12 divided by 3, plus 8 over 3, which is 8 divided by 3. Excuse me. So then you just graph this line like you did the first one. Your y-intercept will be 8 over 3, so 8/3 on the graph. So 8/3 is just going to be right above the 2, right there. And then for my slope, kind of the same process here. It's going to be negative 4 over 1, or 4 over negative 1. And so we'll go down 4 and to the right 1 again. 1, 2, 3, 4. Now I realize these lines are not the straightest, but something you notice, about each one of these lines, or each one of these slope-intercept forms is that they have the same exact slope, negative 4. But you notice something about their y-intercept. They're completely different. Now we can see that algebraically, that these lines, even though they have the same slope, the same slope, but their y-intercept's different, they're never going to touch because the slope is the exact same and the intercept is different. We can see that graphically, even though those lines aren't very straight, you can see that they never touch at all. So therefore, you're going to have a system that is inconsistent. because the lines never touch one another, they never intersect, they do not overlap, so therefore they are inconsistent since they are parallel and never touch. Now we'll go on to another example. I have written above here, negative 2x minus 3y equals 9, 4x plus 6y equals negative 18. We're going to start by doing the same process, taking this one and making it into slope-intercept form. So it's going to You're going to divide by negative 3 on both sides to get the y by itself. And then we'll graph it. So the negative 3 is all by itself, so that is going to be your y-intercept. So y is negative 3. And then our slope is negative 2 over 3. So that can be treated as negative 2 over 3 or 2 over negative 3. So we're going to go up 2 and to the right 3. So up 2 to the left 3. So up 2 to the left. Okay. Now we're going to repeat the same process for the second one. 4x plus 6y equals negative 18. You're going to take the 4x to the other side and then divide by 6. And what you're left with is negative 2 over 3x minus 3. Okay? So the y-intercept is negative 3. Negative 3. And then the slope is negative 2 over 3. Now, that is just like our case over here. So what are they going to be? They're going to be the exact same line. I can draw it again, but it would be pointless in a sense, because even though these equations look different from one another, they're the exact same line after putting them in the slope-intercept form. So since their y-intercept is different and their slope, since their y-intercept is the same and their slope is the same, this system is going to be consistent and dependent. And this is all due to the fact that both lines in the system both equations create the same exact line, like we just proved here. Now for the last one, 2x minus 2, y equals 2x minus 2, and then y is equal to negative 4x plus 2. These lines are already, these equations are already in slope-intercept form. So we can go straight into graphing them. The first one, the y-intercept is negative 2. So we'll start at negative 2, and the slope is 2, just 2 straight up. So we're going to go up 2 to the right one. Okay, now the second one, slope-intercept is, the y-intercept, is 2. So positive 2. And then the slope is negative 4. So it can be negative 4 over 1 or 4 over negative 1. So we'll do the negative 4 over 1. So we'll go down 4, 1, 2, 3, 4, and to the right 1. Now, after looking at these equations or slope-intercept form equations together, you can tell that their y-intercepts are different. 2 is different from -2, and then also their slopes are different. -4 is different than 2. So graphically, as we have drawn it out, they're going to intersect, but they are not the exact same line. They just touch once and then never again. So this system is going to be consistent and independent. Now, as we review over all these different equations, as we come back to every one of them and wonder, all right, how exactly are they consistent? How exactly are they inconsistent? We'll review, each term by using the graph. When a graph or a system is inconsistent, the lines never touch each other on the graph. But you have to make sure that you check your work algebraically by having them, both equations, in slope-intercept form. If the lines have the same exact slope, but a different y-intercept, they will never touch, and therefore they'll be inconsistent. The next example, with the consistent and dependent case, we can look off of our algebraically from our y-intercept equations, our slope-intercept equations we've created, that they have the exact same slope and the exact same y-intercept. So therefore, they're the exact same line. So once you draw it out graphically, even though you have started off with 2 equations, you only have 1 line on the graph. So therefore, they're always touching, so they're consistent, and they're touching at least once, and they're always touching because they're dependent upon one another. So the 2 lines become 1 in a sense. Then our last case is consistent and independent. Graphically, we already had this one in slope-intercept form. We were given that. They have different y-intercepts, and their slopes are different. So algebraically, we can tell that they're going to be 2 different lines. But, since their slopes are different, as we draw it graphically, we can see that they touch at some point, they intersect, but they continue on doing the same thing. So there's 2 equations, and you can visibly see 2 lines on the graph. So therefore, they're consistent and independent of one. They're consistent as in they intersect, but they're independent because they continue on doing in their own way. So as you can see, consistent, inconsistent, dependent, and independent are all the 4 terms we have discussed in class recently, and play a huge role in determining whether lines intersect or not, and how much. And that can be determined algebraically by putting items into our equation in the slope-intercept form and looking at the slope and the y-intercept, or using graphically by drawing out the lines themselves and seeing whether they intersect or not. Hope you enjoyed this class and enjoyed this time. Thank you.